The perpendicular distance of the point x1, y1 to the line ax plus by plus c equals 0 is the magnitude of ax1 plus by1 plus c divided by root a squared plus b squared. In this example, we want to find the distance of the point 3, 2 to the line y equals x plus 2. We call the point x1, y1 for this formula. Now, we need to get the line in the form ax plus by plus c equals 0. Now, it's not in this form. It's in a different form. As a matter of fact, this line here is in the form y equals mx plus c. So we can actually see what the slope of this line. The slope of this line is the coefficient of x, which is 1. So the line has a slope of 1. And c is the y-intercept, where the line cuts the y-axis. We discussed this in a previous video. By the way, the c for the line in this form is not the same as the c for the line in the form that we need to get it into. The two c's are very different. It's just unfortunate that the same letter is used. So how do we get our line into this form? Well, we just bring everything to one side. You see, we have to have 0 on one side. So if we move the y over to the right hand side, we're going to have 0 equals x minus y plus 2. We normally write down the x term first. So our line in the form that we need it in is x minus y plus 2 equals 0. So now we can write down what a, b, and c are. A is the coefficient of x. So I'll write it over here. A is 1. B is the coefficient of y. B is minus 1. C is the constant term. C is plus 2. By the way, for the line in this form, the value of c is the same as the value of c for when the line is in the form y equals mx plus c. In general, it's not true. It just happens to be the case here. Now, the next thing we do is plug all the values into this formula. So I will call the distance d. So we have the magnitude of a times x1, where a is 1. x1 we see is 3. Then we have plus b, well b is minus 1, times y1, which is 2. Then we have plus c, where c is 2. And this is divided by the square root of a squared plus b squared, where a is 1 and b is minus 1. Well, squaring minus 1 is the same as squaring plus 1, so I can forget about the sign. We get the magnitude of 3 over root 2. Now 3 over root 2 is positive, so the magnitude of a positive quantity is just the quantity itself. If what we get inside here is negative, then we just have to make it positive. To 2 decimal places we get 2.12. So it's 2.12 units, where a unit is this distance here. We could note that when you were calculating ax1 plus by1 plus c over root a squared plus b squared for this point and line, we got a positive result. So we didn't have to worry about the magnitude lines. We got something positive anyway. This is actually positive for all points on the same side of the line y equals x plus 2 as the point 3, 2. So if we were to repeat the calculation for, say, this point here, and we're looking for the perpendicular distance, we would find that this quantity is positive. However, if we were to do the calculation for points on the other side of the line, say this point here, we would find that this quantity will be negative. And then we'll have to get the magnitude of it, because we want our distance to be positive. So points on one side of a line give positive values for this quantity. Points on the other side will give negative values for this quantity. I'll explain more about this in the next video, where I will cover a proof of this formula. In this next example, we're going to find the distance of the point 2, 5 from the line y equals x plus 2. So as before, we have to have our line in this form. A, the coefficient of x is plus 1, B, the coefficient of y is minus 1, C, the constant term is 2. In this case, x1, y1 is the point 25. So we plug everything in, and on top we get 2 minus 5 is minus 3, minus 3 plus 2 is minus 1, and underneath we get the square root of 2. Notice that this quantity in here is negative, because we're dealing with a point on the other side of the line. The point 32 gave us a positive value for this quantity. That means that points on the other side of the line, like the point 25, will give us a negative value for this quantity. So we get 1 over root 2, which is 0.71 to 2 decimal places. Find the distance between the parallel lines y equals x plus 2 and y equals x minus 3. You can see that both of these lines have the same slope. Both lines are in the form y equals mx plus c. The coefficient of x is the slope, so both lines have a slope of 1. The y-intercept for this line is plus 2. The y-intercept for this line here is minus 3. By the distance between the parallel lines, we mean the shortest distance between the parallel lines. So what we do is we pick one point on one of the lines and get the perpendicular distance of that point to the other line. So what I've done is I'm using the point 0,2 on this line, and I'm going to get the perpendicular distance of it to the second line. So we label the point 0,2 as x1, y1. We need to write the equation of y equals x minus 3 in the form ax plus by plus c equals 0. So we need to have 0 on one side, so we need to move everything to one side. So I'll move the y over to the other side, and I'll write the line as x minus y minus 3 equals 0. So we can see that a is 1, b is minus 1, and c is minus 3. So we plug everything into this formula. So a is 1, x1 is 0, b is minus 1, y1 is 2, and c is minus 3. We divide everything by square root of a squared plus b squared. B squared is just the same as 1 squared. So we get 0 minus 2 minus 3, that's minus 5. The magnitude of this quantity is just 5 over root 2. So to 2 decimal places, the shortest distance between the parallel lines is 3.54 units, where a unit is this distance here. This is 1 unit. The point 41 is 5 over root 2 units from two lines that intersect at the point minus 1, 1. Find the equations of the two lines. So here's the point 41. Its perpendicular distance to the two lines that intersect at minus 1, 1 is 5 over root 2. Now we have to work backwards here. We know the perpendicular distance, but we don't know the equation of the line. But we know that each line passes through the point minus 1, 1, so we can write down the equation of the line. We don't know the slope, so we'll just call it m. So this is the point x1, y1. Well, we're getting the equation of say, this line, or any line passing through minus 1, 1. That's what we have to do first. So here is our equation formula. So we plug everything into this. So y1 is 1, m we leave as m, and then we have x minus x1. So it's x minus minus 1. So we get x plus 1. And multiplying m into this, we get mx plus m. Now, we want the distance of the point 41 to the line. So we need to write the equation of the line in the form ax plus by plus c equals 0. So we'll have to bring over everything, y minus 1 to one side. We'll have to write our equation like this: mx minus y plus m plus 1 equals 0. Now this line is in the correct form. You see that a, the coefficient of x, is m, b, the coefficient of y is actually minus 1. And what about c? Well, c is the constant term at the end. So c is is m plus 1 basically. You see, this is just a constant. M is just a number. So we have no x or y appearing in this. So c is actually equal to m plus 1 for this line. So this is the equation of any line passing through the point minus 1, 1. The slope is m. M is what we need to determine. If we know what the slope of a line is passing through the point minus 1, 1, then we have the line. So we know that the distance of the point 4, 1 to this line is 5 over root 2. So we apply our distance formula. And I've written down what A, B, and C are for the line. So this is a general line that passes through the point minus 1, 1. So A, the coefficient of x, is m. x1 is 4. B, the coefficient of y, as you can see, is minus 1. y1 is 1. And then we have plus c. Well, c is the constant term at the end. That's m plus 1. And this is divided by root a squared plus b squared. So we have root m squared and we have minus 1 squared. Well, that's just 1. And this must equal 5 over root 2. So we just have to work back to find m. We will actually find that there are two values for m, because there are two possible lines that satisfy the conditions here. Simplifying the top here, we get just 5m. These cancel. Now, this equation here is really two equations in disguise, depending on whether 5m over root m squared plus 1 is positive or negative. So if what's inside the magnitude lines is positive, then we can just drop these lines and write 5m over root m squared plus 1 equals 5 over root 2. So that's one equation. So this is for the situation where 5m over root m squared plus 1 is positive. We get this equation. The other situation is if 5m over root m squared plus 1 is negative. If it's negative, then when we get the magnitude, we will make it positive. But that's the same thing as sticking a minus sign in front of it. So either it's positive or negative, or we could say it's positive or equal to 0 to be more precise, but it doesn't really matter. It's not going to be 0. M is not going to be 0 anyway. But if it's positive, as I said, we can just drop the lines and we have this equation here. We can solve it. If it happens to be negative, then we want to get the magnitude of it. Well, to make a negative quantity positive, we minus it. We stick a minus sign in front of it. So we get this second equation here. So you could say we're solving two equations in disguise. However, if we simply square both sides of, say, this equation, then we will be able to solve both equations. See, if we square both sides of this, we'll get the same result as if we squared both sides of this one. Because when we square, the minus sign will disappear. So all you need to do really is just square both sides of this. The value or values of m that satisfy this equation will also satisfy it when we square it. Similarly, the values of m that satisfy this equation will also satisfy the equation got by squaring this equation. So we just square both sides, and this is what we get. Cross multiplying gives us 50m squared equals 25m squared plus 25. Solve this equation. 25m squared equals 25 means that m squared equals 1. The square root of 1 is either plus 1 or minus 1. So we get two values for m as expected, because the conditions of this problem lead us to two possibilities, two possible lines. So one of these lines has a slope of plus 1. Well, we can see that obviously it's this one here. This is the line with positive slope, and this line here has negative slope. So here's the equation of any line that passes through the point minus 1, 1. So if we want a line with slope 1, which is this line here, we just plug 1 in for m. So we get 1x minus y plus 1 plus 1 equals 0. So we get x minus y plus 2 equals 0. And as for the other line, m is minus 1. Just plug minus 1 in here, and we get minus x minus y plus minus 1 plus 1. That will give us 0. So we rearrange this equation. We see that it's actually y equals minus x. We want to rearrange this one to get it in the form y equals mx plus c. We will get y equals x plus 2.